Welcome back to our lecture series on material science and metallurgy subject. In today's topic, we will discuss about ferrous and non-ferrous alloys. The fundamentals we will see. So we'll briefly look at the basics of alloys, and we define the ferrous and non-ferrous alloys. Then comes to the classification of metal alloys. We will see how broadly metal alloys have been classified, we will see, and we will come into first ferrous alloys. We will discuss some of the advantages and limitations of it. Then we will jump into the steels. Under ferrous alloys, again the categories of the steels and cast iron, so we will jump into steels. Within that, based on the carbon content, we will be subclassifying it into which one of the steels, that is low carbon steels, we will discuss in today's class. Its composition, microstructure, properties and applications. So understanding the foundation of structural materials in engineering is very important. It helps in designing stronger and durable components. Alloys form the backbone of modern manufacturing and construction, as we are all aware of it. And this session mainly focuses on two main topics, that is ferrous and non-ferrous alloys. Its applications ranges from cars and bridges, from there to electronics and whatnot, into the aerospace and other domain as well. If you recall how we had defined an alloy is a metallic material that is composed of two or more elements where at least one need to be a metal. This is how we have defined in the unit 2. And basically these alloys are created to get the improved strength and corrosion resistance or the machinability. Engineered properties are better than the pure metals, we all know that. So alloys fall under this category. Alloys does fall under this category. These are engineered materials, so their properties are better than always pure metals. So they are mainly used in mechanical, electrical and structural components. For example, if you look at steel and brass, they have multiple applications in the mechanical and other structural components. And steel is an alloy which is made out of iron and carbon. Iron is the principal base metal and carbon is a primary alloying element. Similarly, in the brass, copper is a primary base metal and zinc is a primary alloying element. So enabled customized properties for different applications. So alloys will enable us to customize the properties according to our desired application. It can improve the performance, it can improve the safety of the products, and it can improve the lifespan of the products. So this is what alloys offers to us. And it can reduce the weight, it can improve the thermal or electrical conductivity as well. And these alloys are essential in sectors, especially like aerospace, space applications and automotive industries and medical devices and the products as well. So alloys allow the cost-effective manufacturing, and it also mass production of the materials is also very much possible. So let us define these two materials, ferrous alloys and non-ferrous alloys. So by virtue of composition, metal alloys are classified into two categories. One is the ferrous, other one is the non-ferrous alloys. So ferrous alloys are nothing but these are the alloys that contain iron as the main constituent component. So iron is the base metal in the alloy. So such kind of alloys are called as ferrous alloys. For example, steels and cast irons. So in the case of steel is a mixture of iron and carbon, iron being the base metal In the case of cast iron as well, iron is a base metal and carbon is a primary alloying element. The non-ferrous alloys are the alloys that does not contain the iron as main constituent component. So as an alloying element, iron can be present in the alloys but not as the base metal. So for example, all the copper alloys like brass, bronze and aluminum alloys. In the case of copper alloys, copper is a base metal and the alloying elements could be of tin, zinc, etc. And similarly, aluminum alloys as well. Aluminum is a primary or the base metal. So if you look at the broad classification of metal alloys as we have discussed, primarily divided into two categories based on the base metal that consists of. Ferrous alloys being with the iron and non-ferrous alloys without iron as the base metal. And further, ferrous alloys can be classified into cast irons and steels. So we have the steels here and we have cast irons both. So further, these steels are subclassified into low alloy steels and high alloy steels. So low alloying, that means it's not heavily added with the alloying element. The alloying element concentration is lower in the steels, so we categorize them into low alloy steels, and relatively higher the alloying concentration, so that is those steels are high alloy steels. So based on the carbon content, again these low alloy steels can be subclassified, or these are also called as a plain carbon steels. Only carbon as the alloying element, these steels can be considered. So based on the carbon weight percentage, again these are subclassified into three categories. One is low carbon steels, then we have medium carbon steels, then we have high carbon steels. And further, these are also considered to be the plain carbon steels and high strength alloy steels, HSLA in short. And similarly, medium carbon steel also, it can be present as a plain carbon steel, and further if it is added with additional alloying elements, it can be turned into heat treatable steels. Then similarly, high carbon steels can be present in plain carbon steel mode as well as the tool steels, provided the additional alloying elements have been added. And when it comes to high alloy steels, they are subclassified into again tool steels and stainless steel. They are stainless steel along with the carbon alloying, and the silica is going to be primary alloying element, which is a primary reason for stainless steel to be corrosion free or having high corrosion resistance. So the classification of cast irons we will see in our upcoming classes. For the time being, we will stick with the steel, the classification of the steels. Going ahead, if you see the advantages or importance of ferrous alloys, they are especially important as engineering construction materials. So any engineered materials, if you are seeking for, so these are the primary lookout materials, ferrous alloys, and their widespread use is accountable for mainly three factors. Why they are widely is being used is accounted by three factors. One is iron containing compounds exists in abundant quantities within the earth crust. So first one is the base metal is, for these ferrous alloys, the base metal is iron. So iron containing compounds or in the iron ore or any other ores, the iron containing compounds exists in abundant quantities. That is one of the primary reason why mostly people go with ferrous alloys. And another factor is metallic iron and steel alloys may be produced using relatively economical extraction. Economical way, it's extraction, right from its extraction from the earth crust, and its refining and further alloying and the fabrication techniques into different products. So the entire cycle, this entire cycle, extraction, refining, alloying, and fabrication techniques, this entire cycle is relatively economical. It's relatively cost effective. Then the third factor could be ferrous alloys are extremely versatile. So you can get a property range, you can tailor your properties into your desired application. As per your desired requirement, we can tailor the properties of these ferrous alloys. And so these are extremely versatile in that they may be tailored to have wide range of mechanical and physical properties. These are the primary three reasons why ferrous alloys are being widely used in most of the engineering construction materials. Okay. Yeah. However, these are also having certain limitations. The principal disadvantage of many ferrous alloys is their susceptibility to corrosion. So, as iron, we are aware that iron is prone for corrosion. It forms, it reacts with the oxygen and forms into iron oxide, and that will deteriorate the properties of the material. So, this is the primary limitation that we have with the ferrous alloys. It's a poor resistance to corrosion and oxidation at high temperatures. Then ferrous alloys does not retain their hardness and strengths at higher temperatures. So when they are brought to higher temperatures, its properties, its strength and hardness will not be retained at the designated level, which is present at the room temperature. They tend to reduce. As the hardness of material increases with the addition of carbon content, the ductility and toughness decreases. So we have the contrary, like when you keep on add carbon to the iron, so you can expect the hardness, the improvement in the hardness, but however, which is at an expense of reduced ductility as well as the toughness of the material. So balanced properties need to be maintained according to the desired requirements and the end application. So as we have seen, the ferrous alloys have been further classified into steels and cast iron. So we start with discussing on the steels, then we will, in the later upcoming classes, we will also discuss about the cast irons. Steels are iron carbon alloys that may contain appreciable concentrations of other alloying elements as well. So the primary alloying element is a carbon and the base metal is the iron. Base metal is iron and primary alloying element is a carbon. In addition to this iron and carbon, there could be a presence of other alloying elements. Depending on our desired properties, we will be adding the alloying elements into the ferrous alloys. The mechanical properties are very sensitive to the content of carbon. The mechanical properties of these materials are highly sensitive to the presence of carbon, how much presence it is having. So normally, which is less than 1 weight percentage, it shows a significant difference in its mechanical properties. Above 1 percentage, the deviation is not that great. So it's not that significant. It maintains a relatively closer strength, closer mechanical properties. So we have plain carbon steels based on the carbon content, which contains primarily the carbon as a alloying element, and the remaining will be very less residues of impurities will be there other than the carbon, and a little manganese could be present. So these are plain carbon steels. Iron along with the carbon, primarily along with the carbon, and there will be no presence of other alloying element to a significant level. So except this little proportion of manganese could be present in this plain carbon steel. So such kind of alloys we call it as a plain carbon steel. So we have another steels, that is alloy steels, where along with the carbon there are more other alloying elements are also being intentionally added for specific concentrations. So they are categorized into alloying steels. So first we will discuss plain carbon steels. If we go back and look at the classification of metal alloys, so here we can look at these low alloys, or we can also say as plain carbon steels. Here we have the plain carbon steels, that is based on the carbon percentage. You have low carbon steel, and we have medium carbon steel, then we have high carbon steel. So these three are the plain carbon steels, and these are alloying steels, tool steels and stainless steels. These two are the alloying steels. So let us start discussing about plain carbon steels first, and before that we look at the effect of carbon content in the steels. As the carbon content is increased in the steel, how the properties are changing. So as the carbon content is kept on increased in the steel up to 1 weight percentage, it increases hardness of the material as well as the strength of the material. So both the hardness and strength will be improved. Then it will, on the contrary, it will decrease the ductility and toughness of the material. It will increase the electrical resistivity and coercivity. It will decrease the thermal conductivity as the carbon is increasing, and magnetic permeability also is decreased, and it decreases the weldability because it obstructs the welding ability of the material. So it reduces the weldability of the material as well, and it decreases the machinability as well. Okay. So this is the effect of carbon content. So it reduces, it only increases the hardness and strength of the material as the carbon is increasing. On the contrary, it decreases the ductility, toughness, electrical conductivity is decreased, thermal conductivity is decreased, and weldability of the material is decreased, and machinability is also decreased. So we'll look at low carbon steels. We'll jump into low carbon steel. If you look at the composition of the low carbon steel, among all the different steels, those produced in greatest quantities fall within the low carbon classification. So the majority of the steels what we produce today, they fall under this low carbon classification. So the carbon percentage, if you look at here in the iron, so this is less than about 0.303 weight percentage of carbon, and there is a small presence of manganese up to 0.4 weight percentage, and the remaining bulk will be iron with traces of impurity. This is a composition of low carbon steels. It is less than 0.309 weight percentage of carbon. So it can be strengthened. These are unresponsive to the heat treatment process, as the carbon content is very less in the alloys, in these steels. It is unresponsive to the heat treatment process, so hot working strengthening mechanisms are not that effective. So it can only be strengthened by cold working processes or cold working techniques. If you look at the microstructure, it consists of alpha ferrites and perlitic constituents. So if I can show the microstructure, so these bright regions indicates the alpha ferrite, and these dark regions that indicates the perlitic structure. And perlite is the combination of again cementite and ferrite. So perlite is it's considered to be having alternative layers of ferrite and cementite. The dark phase, if you magnify and see, look at it. So this is a perlite, and which is the dark phase in the carbon-rich cementite, and within this, the bright phase indicates the light phase indicates the ferrite. So this is the microstructure of low carbon steel. If you look at the properties, these alloys are relatively soft and weak, as the carbon percentage is very low. It is soft and weak, and they possess outstanding ductility and toughness, because the hardness is low, and it can possess the high ductility and toughness. They are machinable and weldable, so carbon percentage is low. Of all steels, these are the least expensive to produce. Among all the other steels, these are the least expensive to produce. These are some of the properties of low carbon steels. And strength is relatively low when compared to the medium and large carbon steels. And if you look at the applications of these low carbon steels, mild steel is one of the material that is widely used under these low carbon steels. Typical applications includes automobile body components uh, and structural shapes like I-beams or channels or angle irons, and these are the primary applications. And along with this, it's a sheets. Mesh sheets are being widely used in pipelines, buildings, bridges, and tin cans, etc. These are some of the applications of low carbon steels. So, if you summarize in a total, we have emphasized that the knowledge of alloys is key to selecting the right materials in its design for the engineering applications. And the proper alloying, the choice of alloy affects the overall performance and cost and durability of the product. And alloys are vital for material performance enhancement. And if you look at ferrous alloys, they are strong, cost effective, and widely being used because of their abundant presence. It's base metal abundant presence in its earth quest. We have seen about it. Then engineers, we try to balance the properties, its overall cost, the production cost, and the environment. So for making this PPT, we have used this textbook by Callister, Material Science and Engineering. In our upcoming classes, we will talk about medium carbon steel and high carbon steels. Thank you for paying attention to this lecture. Thank you.